Okay, so in this video, we are going to use our Kelter strategy to draw something that's a little more complex than a diatomic or something symmetric. So let's look at CO2 first. So this molecule has a carbon and two oxygens. We can look at the periodic table to figure out the number of valence electrons here. So our carbon is going to have 4 valence electrons, and oxygen has 6. So in total, the molecule has 2 times 6 plus 4. So we're looking at 16 valence electrons. Next, we need to figure out how to make the atoms happy. So once again, each one of these atoms wants to have an octet. So in step 2, we're looking at 8 times 3, which is 24. Next, we're going to figure out the number of bonds, which once again is we take step 2, which is 24, minus step 1, which is 16, and divide the whole thing by 2. So we're looking at 8 over 2. So our molecule is going to have 4 bonds total. Now this is the part where step 4 becomes important. We have to decide which one of these atoms is the least electronegative. And you can do that by thinking about the periodic trend. So moving from left to right across the periodic table, we're becoming more electronegative. So because oxygen is farthest to the right, we know that to be the most. So carbon is going to be our least electronegative, and therefore the central atom. Carbon, as we know, also, well, maybe you guys know from organic chemistry, is tetravalent, means it usually has 4 bonds. So we're going to draw 4 bonds for carbon, bonded to each one of the oxygens, as such. So now carbon has a full octet. It has 2, 4, 6, 8 electrons. So we have to place the remaining 8 electrons on both of the oxygens. So 1, 2, 3, 4, 5, 6, 7, 8. So once again, that's 2, 4, 6, 8, 10, 12, 14, 16. So now we filled up the outside electrons, or the outside atoms with the electrons. If there were any leftovers, they would belong to this carbon, but there aren't. So we have 16 electrons total, just as we should. So this is the Lewis structure for CO2. Let's look at another example. So let's look at this compound, PCl3. We're going to go through the same process here. We're going to look at the valence electrons. So phosphorus is going to have 5 valence, and chlorine once again has 7 valence. And this is coming straight from the periodic table. If you don't know how to do this, please send me an email and we'll talk about it. So the total number of electrons in this molecule is going to be 5 plus 7 times 3, because there are 3 chlorines, so we're looking at 26. To make this atom happy, we're looking at an octet for each, so 8 times 4, so there are 4 atoms, so we need 32. And finally, let's compute the number of bonds. So we're looking at 32 minus 26 divided by 2, and that is going to give us what? 6 over 2, so 3. So this molecule is going to have 3 bonds. Once again, we have to decide which one of these atoms is the least electronegative, and we look at our periodic table. Chlorine is more to the right than phosphorus, so our central atom is going to be phosphorus. Phosphorus is going to have 3 bonds, 1 to each chlorine. So 1, 2, 3. So far we've used up 2, 4, 6 of our 26 electrons. So we need to fill up all of these chlorines so that we can reach 26. So we're at 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we filled up all the chlorines, and we only have 24 electrons used up. So once again, any leftover electrons are going to go on the central atom, so that means our phosphorus is going to take 2. So that brings us up to 26. The final thing you should do is check that every atom has a full octet. So chlorine has 8, all the chlorines have 8, and then finally phosphorus is 2, 4, 6, 8, just as it should. So now everything has a full octet, and this is our Lewis structure for PCl3.